Just like we have like terms and unlike terms when we're talking about variables and their exponents, we also have like radicals and unlike radicals. And it's got to do with what is underneath the radical sign. So these are like radicals. These are unlike radicals. Notice it's got to do with this portion here. So they're like radicals, we can add and subtract. That's okay. Unlike radicals, we can't add and subtract. So for instance, there's not anything we can do here. Okay, this is as simple as it gets. But there is something we can do with this one. 3 and radical 5 plus 2 radical 5 is actually 5 radical 5 because you add the 3 and the 2 together and just have the radical 5 on the outside. Just like you would with 3x squared or 2x squared. It's like having like terms, except in this case they're like radicals. You can also subtract like radicals. Say we have radical 3 minus 5 radical 3. In this case, think of radical 3 like it almost has a 1 out front, even though we're never going to write the 1. And 5 from 1 gives us negative 4 radical 3. Right, same idea as before. It's not always going to be obvious that you can combine radicals or that the radicals are like. For example, you might have something like 5 radical 3 minus radical 12. Initially, you might say to yourself, well, those two aren't like, there's nothing I can do. However, radical 12 can be simplified. It simplifies to square root of 4 times the square root of 3, which is 2 times the square root of 3. So now, I do have like radicals. So I can do my subtraction. We can also multiply radical expressions. For example, the square root of 10 times the square root of 6 plus 3. We can do distributive property. The square root of 10 times the square root of 6 plus 3 times the square root of 10. The square root of 10 can't be simplified at all. This can be combined, though. We can do 6 times 10 underneath the radical sign, giving us the square root of 60 plus 3 times the square root of 10. And the square root of 60 can be simplified into the square root of 4 times the square root of 15, or 2 root 15 plus 3 root 10. Is there any other simplification we can do here? No. That's it. That's the extent of it. We can also sort of deal with this thing like foiling. So here we have what is essentially a binomial, or two unlike terms together. And we're going to multiply it by another binomial, two other unlike terms together. And you do the same process you would with FOIL. Remember, first, outside, inside, last. So square root of 6 times the square root of 6 is the square root of 36, or just 6. Outside, the square root of 6 times the square root of 3, that's the square root of 18. There's simplification available there. We'll deal with it in a second. Inside, the square root of 2 root 3 times square root of 6 is negative 2 root 18. And then finally last, negative 6. 6 and negative 6 cancel each other out. The square root of 18 can be simplified in both cases so that we have 3 root 2 minus 6 root 2, which is simply negative 3 root 2. We also have something called conjugates. And conjugates are the sum and difference of the same two terms. For example, the square root of 7 plus the square root of 3 and the square root of 7 minus the square root of 3 are conjugates. Okay, and it works kind of like difference of squares if you think about it. So difference of squares, if you remember, was like x squared minus 4, and that would factor to x minus 2 and x plus 2. Well, here we're sort of going the other way, right? So square root of 7 plus square root of 3 times square root, square root of 7 minus square root of 3. See, same two terms, but one's with plus, one's with minus. That's just equal to 7 minus 3, or 4. And if you FOIL that out, you'd find out the same information. Okay? It's just easier if you recognize conjugates when you can. How would you use conjugates? Well, in a problem like this. Let's say we have 10 over the square root of 7 minus the square root of 2. Now, to rationalize denominators in the past, I've told you to multiply by the denominator over the denominator. But there's actually another solution for a problem like this, using the conjugate. If we multiply by square root of 7 plus the square root of 2 over the square root of 7 plus the square root of 2, noticing because I have the same thing on top and bottom, I'm not changing the value of the fraction. I'm just multiplying by 1. It's just a weird looking one. This bottom, these are the two conjugates. So this simplifies to 7 minus 2, or 5. And the top simplifies to 10 root 7 plus root 2. Okay, over, so the bottom's 5. And we can simplify this because 10 and 5 cancel each other out. This is a 2, this is a 1. So now we have 2, and if we do distributive property, 2 root 7 plus 2 root 2. And that would be our final answer. And that's preferable to what we start off with, because what we start off with had radicals in the denominator, and we don't want radicals in the denominator. Okay.